Hello, everybody. So one thing that I'd like to ask that while we run through the presentation, if you could take the time to answer some survey questions that we have in here. We're actually compiling an ebook that will be made available after, a little bit after the presentation, which will include the results of many of your answers. There's a lot of people who have joined this this webcast, so statistically that starts to create a kind of nice view of some of the things that people are thinking about, some of the concerns, and some of the things that they're trying to get done. So to get kind of a market shot of what's happening, a snapshot, that's something that would be useful to get your voice heard in and see how that relates to what everybody else is doing. And of course, all the information is anonymized. So, okay, welcome to this webcast. We're going to be talking about information modeling as it's implemented with OPC UA and what advantages that gives your products. So to start off, I know there are a lot of people here, so there'll be probably different levels of knowledge about OPC UA and some of the details. Just you know, forewarning, this is not an introductory webcast to everything that OPC UA is. This is intended specifically to narrow down towards the benefits of using information modeling. And how OPC UA really opens that up and makes it practical in the, let's say, era of interoperability. Okay, so there's some of the sort of high-level topics I'll talk about is a very brief introduction to OPC UA. I'll talk about OPC UA companion specifications and how that relates to information modeling. Quick introduction, and again, conversation about what information modeling is. And then Cause will take over, and he will actually run you through a process of how you would create an information model, how would you implement that into an OPC UA server and actually interact with it and such. So he'll go through that part, and then we'll run through some questions and answers. All right, so let's start off with an overview of OPC UA. So one of the things to understand is that get an idea of where OPC UA applies. And as it turns out, OPC UA applies everywhere. That, you know, that claim isn't often made, or at least is hard to meet generally, but as it turns out with OPC UA, it's the reality. Okay, so OPC UA as a communications or interoperability platform is used at the lowest levels down to sensors and devices and actuators, at the control or the operations level, and also when you're talking upwards, whether it's to cloud type solutions or throughout the enterprise on the business side. OPC UA comes from, of course, its predecessor, which is OPC Classic. OPC Classic, in a nutshell, solved the problem of interconnectivity at the operations level. OPC UA basically takes that, you know, as the next generation does. It doesn't just take a small step. It does a, you know, order of magnitude step where basically not only does it address modern concerns about interconnectivity, which also address security, but also expands and takes into account interoperability or facilitating that, which is where information models play a key part in. Okay, so the only thing that I'll talk about about OPC UA in general are, let's say, the top four. It's actually top three points about OPC UA, but one of them splits sort of into two views, just to be clear or to show you the difference in the detail. So the highlights about OPC UA: it's an open platform. It implements strong data security. And it facilitates interoperability both at a, say, data connectivity or exchange of data level, and also through services or the ability to actually act on that data using a service architecture. So I'll go through each of these in turn. So for the open platform, OPC UA can run basically on any platform. So whatever type of hardware you're running on, OPC UA will run on that. So whether it's larger, you know, so the Intel PC type processors, smaller ones, ARM-based architectures, it runs on all of those. It's operating system agnostic. It can even run on systems that don't have an operating system. It's able to model or to deal with, to transfer the data for various connectivity standards, and also just as OPC Classic did, you know, the small fraction that sort of stays the same as before, it's able to translate from one protocol, let's say, to another. But that's a tiny part of what OPC UA has become. As far as data security is concerned, OPC UA has been extensively tested in Europe by the German federal government, the division responsible for communications and communication security. So basically, they've run exhaustive tests on it and basically found that out of everything that's out there, the practical way to implement to implement data security in a control automation type context where you're exchanging information and you're actually securing the data end to end, not just while it's traveling, but basically from the time from the source to the consumer, not just the in-between sort of legs of the transport. So OPC UA has been recognized as a secure method of exchanging information. So the key parts about interoperability, number one, has to do with data. So the ability to create information models or the structures, to model the structures that various products would have. What I show here is at the bottom you see those three different colored squares, and they have their own data structures, let's say. Those are the shapes that are represented by the different, colored shapes there. And then you have a client or the consumer of the data that's OPC UA enabled. Now, by having an OPC UA server on board each of these devices, what that allows you to do is to create a model of the information, the relationships of the data that the device natively uses, and express that relationship using the OPC UA method of modeling information. The reason that's important is, number one, it preserves and leaves intact whatever is required for the actual information models that a device that was designed for a particular industry required. So if you're in building automation, you might be using the BACnet. If you're in a different industry, you might use a different protocol. Might be simple, might be complex, might be object-oriented, might have states. All of that can be expressed in an OPC UA model. Now, the reason that's important is while you're maintaining the relationship and the behavior in the device in the context that it operates in, at the same time, you're making it possible for third-party systems, like, for example, the UA client that we're showing, to actually traverse and understand, or at least be able to identify what the relationships are between those different information model components, but using OPC UA. So that allows the UA client now to start connecting to various devices which have different information models themselves and be able to still traverse them and work with those information models as though they were native, as opposed to having to pick them apart or basically hard code what that model is into the UA client. It can discover and work with the model that just it happens to find on a UA device that it's connected to. Now again, I won't keep repeating this, but this is all done in a secure environment. So when I talk about the ability to do this, everything is preempted on the fact that you had the authorization to do it, right? So it's not an open book where you can come in and get anything from any device. It's you can get that if you have the security authorizations to do so. So the second part of this, which becomes really important now in the IIoT and the Industry 4.0 type era, is that with this massive amount of information and all these models floating around, one of the key things is what do you want to do with that information and how do you want to put it to use? And the key point there is that when you have a device, instead of just trying to work with the information model as a data structure, you actually want to work with that device or that product as sort of the agent or the actor that it is in whatever it is that you're doing. The way to do that is to basically just take advantage of the services that device offers without having to know how they are explicitly coded or a specific language to talk to them via a particular API that particular vendor uses. So in this diagram, what I'm showing is, again, a client that's capable of working with OPC UA commands, which are basically how you work with the services that the devices might expose. And then on a device, in each of the devices shown, vendor 1 and vendor 2, the different colors of the sort of flowcharts that appear, those would be the different types of commands that are defined to perform a particular action. But what happens is when you have an OPC UA server on board that device, again, it doesn't disrupt what you have as an API or a method of providing services by that device, but it now exposes them in a standardized fashion through OPC UA. So just as below, you can see that it's got the OPC UA data structures, or the information model from a data relationship perspective. The same way, you're also exposing in a standardized way let's say the verbs of the device, right? So if the data relationships are the nouns that basically just store information and say what the relationships are, the commands would be the verbs, which say what can you do with that device, or what can that device act on. So when the clients connect, just as they can understand and work with the data relationships, they can also call on various functions that device would perform. So that these two, that's how I said these are kind of like these last two tabs or the pages are kind of one point, and that's for interoperability, whether you're dealing with the data or the services aspects. Both are required to really drive the interoperability. So now the key thing to kind of bring all that together now is there's really 3 points to make. So number one, OPC UA defines how you create these sort of, let's say, universal information models. And when I say universal, that means the definition, the method of defining a model is universal, so that when someone else creates a different model for a different application, the method of expressing that model is the same, because it's all based on OPC UA, which gives you the flexibility to model virtually anything that you would in your own context, but it's expressed in OPC UA. Now, the domain experts in each of the industries or everything that whatever they happen to be working on, they define the what, right? So the information model in the end has to represent something on the device, whether it's a robot arm or it's some kind of spectrum analyzer or whatever the device happens to be, that the experts will know what they're trying to model. They're just going to utilize OPC UA to create that model. Now, the second or the next part of that that's extremely important is, of course, trying to then define and gather these types of standards to say, okay, well, since there are many common types of devices, it would be good if they could use, or the community that works with them could agree on what type of standards everyone will adopt, so everyone can use the same information model. So just like we have ISA 95, for example, that helps to model and identify various assets and things across entire plants, the same way, basically, that starts to happen. Say, okay, well, if you take that, how do you encode that and make a specification, an information model of a particular framework, for example, that's defined, so that everybody who uses OPC UA could work with that. That's what we call companion specifications, and they are basically each companion model that's created that builds on top of the base of what OPC UA provides. That's what we call the companion information model, and they're all gathered together. So when we look at this, you know, there's many different ways to slice and dice industries and levels in the company, and the verticals, or even the focus of the modeling. So, I mean, it just taking a smattering of different sort of ways of looking at it. You could have low-level sort of modeling where you're looking at what different either buses are doing, or you could go a little higher and start really high and start looking at sort of the high-level view, like ISA 95, or sort of broader view, I guess, not higher, or just specific verticals where you've got industry interests, where people are expressing things of how the data, what are the relevant data models or information models used in their particular industry or what they're working with. So the OPC Foundation on this point actually has many collaborations, collaborates with various organizations, and to sort of assist with you know, either providing some information on how to best utilize OPC UA, and also just to collaborate on how, you know, OPC UA purely domain knowledge can be used for expressing the models that these various organizations are trying to create. Now, there's so much activity happening here that I would encourage everybody to actually check out the OPC Foundation website. The link is given here, because they change often. So The graphic that I'm showing here that shows the collaboration between some of the main organizations, I mean, that actually changes quite quickly because, again, as OPC UA continues to accelerate in the adoption phase in the market, you know, there's obviously much more activity. Now, that's all I'm going to say about, you know, these companion specifications, which, again, now you know are basically various information models that would be accepted or used by various organizations that have a common requirement or need to use them for. So that's sort of the overview of how information modeling ties in. Now let's basically go and take a look at the actual information modeling itself and sort of what, you know, how to visualize and how to understand what information modeling is about. So the easiest way to do this, I thought, would be to just take a look at a physical asset. So let's say you've got a robot and it's got various points. I just added some, you know, those crosshairs are little data points that you might be looking at on the robot, say a welding robot. So this is what you would have as a physical asset. Now in today's sort of lingo, especially if you're dealing with Industry 4.0, but also in the Industrial Internet of Things, we talk about cyber-physical systems, right? So that basically means that you got a physical asset that is properly modeled and represented in cyberspace, because in the end, it's the interaction of the various information models in cyberspace or in sort of the digital side of things, where, you know, their data and the services that they provide, all those interactions happen there, and the physical assets basically then execute on that and do it. So in that sense, we would call the information model and all the information associated with that information model for a given physical asset. We would say that when you bring those together, so the data relationships, the services that act on them, and all the data, that's come, I show them in two different boxes above and below. If you bring all those together, that's really what you would call the digital twin, right? So just for ease of reference, that's what I'm talking about when I refer to something as a digital twin. It's the sort of cyber representation of the capabilities and states of a particular system. So now when we shift over to how implementation of this would work, what we find is that, number one, you've got this robot, and of course it's got processors and, you know, all sorts of subsystems within it to operate all the components and keep diagnostics running and such. So you are going to have a model and a relationship between the various components, and those both include, again, there would be some actions that it can perform that could be exposed, and also the actual readouts, either read or write points on it. So basically, if you're creating an OPC UA server, which would then act sort of sits at the heart of this interface between let's say what makes a digital twin sort of accessible or visible to the outside world, it would be through an OPC UA server. So in this case, where of course Matrikon provides a OPC UA SDK for building the OPC servers and clients, OPC UA. So in this case, what you would do is you're taking you would code, and of course, both for the interaction with the data, the reads and writes, whatever, interfacing with the physical system and the information model, and you would implement that via the Flex into an OPC UA server. So this now creates your gateway or entry into sort of this cyber-physical world. That's how the world interacts with your physical asset, through this OPC UA server. However, given the complexity and how much you have to work with the models, there's a lot that has to get done there, because of course you've got, the more components you have and the more services that are exposed and the more that you know, you have to work with that and make revisions and such. One convenient thing that you can do is to use a modeler. Now Beeond, who is our we've partnered with them. They are the eco partner in our program, which basically means that they're experts in using our OPC UA SDK, and at the same time they're also domain experts in the development of OPC servers, information modeling, and etc. So they've developed a free modeler that allows you to basically work with this definition in a graphical way and to interact with it. So basically, once that generates this information model that ties the services and the data relationships and all that together, you can just export that information directly into the OPC UA server, which now means that you have a very easy way to control what's happening in the address space of that OPC UA server. What this means, so if this is your product and you have this built in and you're using the modeler and you're using the OPC UA server, what that means is that to the outside world, you've now created basically the ability to interact with your physical asset via this digital twin, a UA-based digital twin, right? So when OPC UA clients or servers that would want to talk to it as well, because in OPC UA you can do both, they basically, when they connect to the OPC UA server, they start to be aware of what are the, like I said before, the verbs, right? So what can the robot do, or what can you do with the robot? Those services are exposed without having to know how that's all coded actually on board the device itself. Okay, so now what we're going to do is, hopefully this, by the way, gives you a good sort of high-level view and feel for how information modeling and the importance of it ties into enabling your device to start to be interoperable in sort of the much broader cyber-physical system sort of view of your plant, of people's plants and field devices and such. So now what we're going to do is I will be handing it over to Kaz to take over, and he'll walk you through what that demo is going to look like.
Yes, thank you, Dak, and hello everybody. So we're going to get into the practical side of the demonstration, which is basically a replica of the scenario that Derek just went through, in which we basically are going to model this fictitious robot in the modeling tool, and then we will see how the implementation of a demo server, which is done with the Matrikon Flex SDK, can just take that modeling definition and use it to instantiate the actual objects and methods and characteristics of the specific definition, which is a robot. And then we'll do a small experiment. We will change that information model configuration in some way. We just create another instance, and just by saving the new model, the server will not need to be recompiled or anything. He will just get the definition and will present that new information into the address space to the clients, which in the meanwhile will not need to disconnect or restart. So I'm going to share my screen, and there's going to be a little bit of codes and tools. So I'm showing now on the screen the rather simple interface of the UA model Accelerator, which is now publicly available on GitHub. You will find the information in the resource list or in the information about this webinar. Anybody can use the modeling tool, and the reason behind it is because the OPC specifications do include all the necessary information to develop modeling and tools, the design models and so forth, and they also specify a model design schema that can be used to generate these information models. Without going into too much details on information modeling aspects, you can basically see that the address space is divided into two main categories. One is the metadata, which is the type definition, and the other one are the instances. You know, there's a whole lot more to it, as you can imagine. But in the type definition, I proactively implemented a type that defines what the robot can do in my demonstration. And the robot type implements values such as speed, what kind of mode is it? Is it automatic, manual, or else? So yeah, unfortunately, there's a little bit of a latency. What you see now is the address space definition, where basically I'm using the tool to define the robot model, and the robot contains information about the axis position. It has 4 axes apparently, and it can also run commands. There are 2 methods. Again, they don't do much. One is a multiply. Of course, it's not a robot method, but it just allows the client to put 2 input arguments and show the result of the multiplication. So I'm looking at the screen and waiting for it to refresh because my computer is going faster than what the presentation is showing. So once the type is defined, the modeler user can then define an instance, and the instance of my robot is called robot1 in this case, and all it does is just implements the type, and I can see the type definition, all the values that the type definition carry with it. So once I have that, all I need to do is to compile what is called the notepad, the information model, into an output directory, and I can also generate code that's part of the OPC specification, the OPC Foundation tooling, that you can generate some code. We just need the node set. The Matrikon Flex SDK will provide everything else needed. So once I compile it, that node set can then be passed to my code. I have my code ready here, and I would need to compile this only one. I just wanted to show the audience, and maybe I can do that that somewhere in the API there are functionality to just load that node set. Again, these kind of services are characteristic of an OPC UA compliant system. So you can load the model from an XML file, and when you run that server, that model can be instantiated. I'm not going to give you the build experience. I'm just going to start the debug executable. So this console application, which is the demo that you're seeing today, which we'll make available as well, is now instantiating an endpoint, which is basically a URL that OPC UA compliant clients can connect to. And I'm using, in this case, I'm using the sample OPC UA client that the Foundation offers on GitHub. So if I connect to that server, in this case, I don't need to fill up anything specific. It identifies my server by its name and identification information. I can connect to it. For sake of time and practicality of demoing, I'm not connecting securely to the server, which is not something you would do in production. But as soon as I connect, I can actually see that instance that I created. And so the client is able to discover that right away. Once I'm in that session, I can then monitor the values to OPC UA subscriptions, for example. That's my axis 1. And that's one way to connect to a server. Another way is what my colleague Andrew did. He actually created a client to visualize that specific robot. Now, this client in particular is aware of that information model. He knows it's going to connect to a robot, as opposed to the demo client from the OPC Foundation that can connect to anything and you just see the values. So this robot is tied. This graphical animation is tied to that server in a way that it knows to discover robot 1, and it animates accordingly. So it moves with that server. What that means is For example, I can turn this in manual mode as a client, and I can change the value of axis 1 to minus 120.2, and I can immediately see that change in the other client connector. This is the CUA classical behavior, expected behavior. Similarly, I can call a method here that multiplies that the server is gonna allow me to multiply two values, and I can stop and start. I can change the speed and everything you can expect this thing to do. The simulation that runs on the server side just applies a sinusoid to the axis to allowing this to move. Now, as a modeler, I might have the need at some point to change my information model, and I want to do so in the tool, for example, just instantiating a new robot, for example. That's an easy thing to do. So I create the robot 2, and as soon as let me just see if the screen is refreshing with my voice. The robot 2, I just select the robot type as a definition as per my information model, and that will bring in all the characteristics of the robot. So having that means that once I save this, I can probably load that into my server. One other thing that I would do is that in order to keep everything tidy, I'm gonna organize my robot using the referencing capabilities of the UA information model. What I'm doing here is I add the ability of this model to be grouped under a folder. So that's called an organized reference in OPC UA, whose target is the object folder in the address space. That's an OPC UA predefined object. It's going to be inverse because it's contained by that folder. And my model is successfully updated, and now I can save it actually, yes, and I can compile it. And as I compile it, it's going to generate a node.set file, that file name that my code relates to, robot server node.set 2. And I don't need to change anything in the code. I just need to copy this newly created node.set file into the directory of my executable. That's how I implemented my demo to load the address space. And that's in this then I just restart the server, and I look at the client, which he might soon realize that, yes, something happened to the server. He went offline, but eventually the client will reconnect. And there it is. It does that automatically, and now you see that you can see two robots. Of course, my animation client has reestablished connection with robot 1. Of course, this client is specifically designed to connect to that robot 1, so the fact that you added another robot doesn't affect this client particularly. But you can see where your modeling capability allows you to change the information model. And I did something rather simple. I just added a new instance. But I could also put a new version of a type definition, a new standard in place. In OPC UA information modeling, I can also implement more than one information model in one aggregated address space and take advantage of the many standards that are available in OPC UA companion specifications to actually create my own enterprise standard that uses ISA 95 empty connect, PLC open. So that's the power of the OPC UA information models, that they can be easily aggregated. So that's basically the end of the demo. As I said, this code is going to be available on GitHub. The modeling tool is already on GitHub, available for people to use. In our site, we have the binaries for people to play. Of course, it's an open source project, and we are going to welcome people using and testing and giving feedback. It's one good way to actually get comfortable with the specification. The demo that you see is just a small example of what we go through in training. You would have a better understanding or deeper level details on what information modeling and OPC UA server development is. So definitely I strongly advise whoever is interested to look at our training page and follow up on that training dates. So I'm going to stop sharing my screen now, Derek. So it's going to go back to the PowerPoint.
Okay.
It does. And of course, I welcome any question in the question boxes.
Great, thanks, Cos. So everybody, I hope you, I hope you found that insightful. As far as again, it's a very quick walk through how the different components fit together. But that's, there's once you know and once you're familiar with the process, it is easy. And I know that Cos is going to grate a little bit on that one, because easy has different implications to it. So maybe just to address that, when we talk about using either our SDK or working with modeling, we often refer to it as being easy. We don't quite use plug and play, but we just say that, hey, it's quick and easy to implement this. One important part to keep in mind is that, easy can refer to either solving the actual problem of what would be a way to express information, or how can you actually get everything to start talking a common way in an ad hoc environment where you've got different third-party systems being brought together. That's one type of complexity or one level of difficulty to solve, which fortunately OPC UA, the standard, was exactly designed and built and defined for doing. The tools that we talk about here, whether it's the Matrikon's Flex OPC UA SDK or the modeler, these are tools that, of course, you have to understand how to use. But the reason we say that it's easy, or I guess we could say easier, is because they take care of the background tasks of how you actually go about implementing those things, let's say from first principles, and they do it in let's say a professional grade type result. So it's, these are things that have been tested and are prepared that when you use them, you can actually start making products that are going into industry where you have a lot of requirements for reliability, security, etc. So with that, just the sort of next steps, or to look at what kind of would be held in the future. Just quick thing about the Matrikon Flex SDK. It's designed to be a high-speed product. It has a small footprint. It's scalable, designed to be you can use it in very small processors, kind of sensor type environments, or you can scale it up to basically talk with literally millions of transactions a second with a massive amount of data points. We've so far, just as a casual test, ran it with basically 1 million transactions a second on basically a standard business laptop, which used about 70% of the 4 cores that were available. But that's, of course, for a larger system. When you go down into the embedded world, it works with that as well. And then basically that's what creates the backbone for your products to eventually plug into, sort of the new era of connectivity out there. So hence why we show the Industry 4.0 and Smart World type graphic here. Okay, so definitely encourage you guys to take a look at that. Now, as far as next steps are concerned, so we've got a sort of the key thing to pull away from here is when we're talking about what Beeond can do for you. They actually have an excellent program that's put together for sort of giving you the 5 steps for how to go about OPC UA adoption, right? So kind of a structured approach to doing this. So the UA standard is already structured on how you work with the data and define relationships and such. But then the question is, what's your process? How do you go about actually, preparing your development team to be familiar and comfortable with working with it? And then how do you, as quickly as possible, actually, get your product out the door, which means you're trying to shorten the development cycles and such. So that's something that Matrikon, really sees value in for what Beeond is doing, and hence part of our partnering. So the OPC UA training, by the way, that's the Beeond does get you up and going, not only with the OPC UA concepts. They also talk about how you would actually use that or how that's implemented with Flex. So we've got training that's coming up, run by Beeond on April 10th. That's the earliest one that's coming up. And then there's also additional training on deployment and migration and such. That'll be in May, as seen on the screen. So the tool, I saw some questions popping up. The tool that Beeond has developed, the modeling tool, UMX, that's available on their site. So that's beeond.net. And of course, if you're going to be building the OPC UA servers or clients, we'd encourage you to take a look at what Matrikon Flex has to offer. It's you can find that at matrikonflex.com. There's data sheets, there's demo versions available for Unix and Windows, and quite a few other resources as well. If you are planning on working with that, please feel free to contact Beeond or Matrikon. We're very happy to either way, people will be happy to help you out and see, sort of what the next steps would be. All right, so that's what we're going to run through here. Yes.
Just one
Go
thing,
ahead.
I just want to mention the fact that the dates of the training that you see on the screen, they refer to a training that we perform virtually, where attendees and students connect to their own virtual workstation and follow on the development activities. So that's a rather convenient way to deliver that knowledge.
Right, excellent. Thanks, Cos. That's actually really important to mention as well. Given today's busy schedules and travel restrictions and such, nothing better than just being able to get a cup of coffee, sit down and in your office and work from it there. So definitely, that's a good point there. It's virtual training, just for I guess to make it as convenient as possible. Okay, so by the way, guys, if you didn't have a chance yet, please do run through that survey. It'll be really interesting to see some of the results, and again, we will be posting them in an aggregated format. We'll be sharing it with everybody who's been attending. So that's what that's about. I guess that's it for our presentation. Now we can also run through some questions. So let's see, we've got a few coming up here. So one of the questions asked, will listeners be able to get access to the UA Model Accelerator Robot Server project? Cos, you want to take that one?
You're referring to the modeler?
And the server project. It appears they're asking about what you demoed, the actual
oh yeah,
robot
absolutely.
project.
We're gonna make it available to the registrants. The modeler tool is already available on GitHub, and but we're gonna send a link to the code for the demo that will allow you to basically replicate the experience. And of course, most of these tools like the demo client and so forth are available on GitHub as well, courtesy of the OPC Foundation.
Right. Okay, and another question, when using alarms and events over OPC UA, which by the way are called alarms and conditions, or AC, is there anything specified regarding data recovery after a disconnection between server and client? Then the secondary part, do vendors implement such capabilities today? Going to answer that, Cos?
Oh, I thought you can fix that. The answer is yes, because those capabilities are actually part of the specification. As an OPC UA mandate, the ability to have redundancy if needed, failover, queuing of alarm and events, and also the vendors do implement at either stack level for specification or SDK level, and definitely Flex does so. So those are available, but they're also expected as being compliant with OPC UA. So just remember that OPC UA is a standard meant for industrial automation, so it has to be robust by definition.
Excellent. Okay, and then the next question, is it possible to connect OPC UA Modeler with the MySQL database?
No, that's not possible. There are two different things. The OPC model is not a data collection, but I know what the question means is that can you serialize an information model in something other than XML? And the answer in general terms is yes. Our modeling tool doesn't do so. We use the node-set XML and everything. But if you were to use, for example, the Matrikon Flex SDK, you can absolutely save the address space and the information model definition into something else that is not an XML file. MySQL as an example, but since the Matrikon Flex SDK is also very well targeted for embedded system who might not have storage, that gives you the opportunity to actually store the information model in binary structures to save the resource of a very small system.
Perfect, thanks. Okay, now somebody was also, and I think this was happening during the presentation, they just wanted to see or know if the functionality of writing values from client to server was possible. And of course you can write to it, but just in the space of what we had for the demo could not be shown. But as I'm sure Cos can confirm, of course, during training you create.
Yeah, that's the first part of training. You read and write. I created a subscription. In many ways, we did a write when I switched the animated demo into manual mode, and I changed the robot arm to position manual front-end. That was basically a write. But yes, read and writes are probably the first lab that you do in training.
Perfect. Okay. So let's see. Okay, would it be possible to integrate the information models into different stacks, for example, Open 62.541?
So we have to keep open. I think that open source OPC UA, if I'm not mistaken. I'm not on the question, so I think it's 62.541, isn't it? So that's
yes.
That's the open source version. That's an open source version of the standard, because the IEC specify OPC UA as a 64.541. So if you're using the Open 62.541, that node set is usable by that stack. For the generated code, if you were to generate ANSI C code, the tool uses the model compiler from the OPC Foundation, so that code generates structure in C for use for the ANSI C stack as the reference implementation from the OPC Foundation. So that those structures may not apply to that, but the node set will. In fact, they actually have that capability. Now, just keep in mind that the Open 62.541 is some sort of a research project, and it does not implement all the information modeling and address space capabilities of a commercial tool like the Matrikon.
Perfect. Okay. All right. So one question, is the robot simulator available for free?
Yes, indeed. Andrew actually put that on GitHub, and that reference. Both the server and the clients, yes, are going to be available. As I said, we're gonna share the links as a follow-up to this webinar, the registration.
Perfect. Okay. Let's see. There's a lot of questions, guys. So I apologize if we don't get to every single question. We will, by the way, be answering these afterwards. So if your question is not read out, that does not mean it got dropped. It just we will be answering those afterwards. So okay, another question that came in: how do you choose at which level to expose your product? For example, the difference between exposure at bus level versus CIP, SIP, over Ethernet IPs, via exposure at higher level with OPC UA. So I think, and Kaz, feel free to add to this afterwards, but basically, I mean, it depends on what functionality you are trying to expose, and I guess the applications where you're using it. So if your product already plugs into an existing system that uses a particular method of expressing the data, and you know, that's sort of the ecosystem that it's working in, then of course you would maintain that. If you're trying to feed data from an existing system and you're trying to open that up to make it accessible in a secure way to the broader sort of usage, then that would be definitely, you know, something to consider then for moving the data off your device using OPC UA. So it really would depend on your application. One thing that I want to note is that, you know, there are many standards that already exist, and they have they've evolved in industries for working with specific types of equipment in different types of environments. So the job and the purpose of OPC UA is not to replace those standards. It's to enable, to, let's say, preserve the knowledge that's stored within those standards, and to provide a, let's say, a universal way of sharing that with the rest of the world so other systems can understand them. And this is especially important when you're mixing third-party systems all together, so kind of an ad hoc combination of different vendors' equipment, because typically most plants and most environments don't just follow something from a single vendor. So that's really the purpose of it. Kaz, is there anything you wanted to add to that, or is that?
Well, that's more than enough, yes.
Okay, perfect. All right. Okay.
Question, if I may.
Yes.
Because we have 2 minutes. Uwe, from there's a question that said that I said that importing the XML node set is required for all compliant OPC UA servers. Which part of the specification said that? Clearly, Uwe is familiar with the specification, and maybe I was a little bit in a rush. It's not necessarily required, and definitely the XML is not a mandate format to use. It is specified actually in part 6. There is an annex. I think it's still the Annex F, which is the information model XML schema specification. Now, that is an annex to the specification that gives the users a way to say, well, you can persist the address space and import and export somehow. You know, they show the XML as a possibility, but as the other person asked about MySQL, how you exchange information model information is somewhat up to you. The foundation proposed the model XML schema, so to have a baseline of a standard, and they publish the node set schema and so forth. So it is part of the specification. It's probably not accurate to say that it's required to comply with the OPC UA specification. So I apologize if I created that small confusion.
Okay, thanks for clarifying, Kaz. There's one, I guess we're running out of time, but one question that I think is important. This is somebody who is curious about, I think the question is pertinent, especially people who are new to OPC UA. It says, how exactly do you interface with physical devices? Does OPC have embedded tools for different protocols, or do you have to use the native API for each protocol? So this is a great question, and something that's important to note, that, you know, if you're used to OPC Classic, which used a, basically it was out, the OPC server lived outside of the device, and in order to talk to the device, you had to access information on the device either by the API that it exposed or by a protocol that it already used. So for example, there might be an API to talk natively to the code running on a processor or a controller, or you talk through Modbus to it to just get information exchanged with it. And that's how the OPC classic server used to talk. What we're talking about here is when you're embedding OPC UA, what that means is it's actually running on board the device. So the way you interface with the device, typically if you're the device vendor, when you're writing your code that's actually going to run dedicated in that device, or however that operating system works within your device, you're actually coding or building the OPC UA server so it becomes a native part of your device. Just like if you think about Modbus, a very common protocol, that's just an example of a protocol, but for illustration's sake it works. The Modbus runs within the device, and you wouldn't necessarily ask how does Modbus access the information on the device because it's actually coded in. So, you might have shared memory. So basically when the I/O registers are filling up memory with the values, basically the Modbus portion of the code exposes that as registers, right? And the rest of the world talks to it that way. The same way the OPC UA server that you're building, it actually lives within the device, and you would then, of course, have access to the guts of the device and expose what you want and control how, which services and which data is exchanged. Now, that's for applications that are native to a particular product, i.e. embedded within it. If you are talking about creating an OPC server that's going to talk from an external point of view to a third-party device or just from outside the device, then yes, you would actually have to have the protocol, or you would have to define how do you natively talk to it. So the OPC UA specification provides basically the boundary that it gets to is how to properly exchange messaging with other OPC UA components. And the underlying part is up to the programmers or the vendors of whoever's making the OPC UA server. They have to identify, well, how natively am I going to talk to the underlying device? That's the part that's hidden from the rest of the world. And the UA interface in the specification basically just worries about how do you actually properly implement OPC UA. Just as if you're defining a Modbus standard, the Modbus standard identifies how the two, how you connect, how the master and slave are going to exchange information, not how does, on the other side, how do you talk to the actual hardware to generate those values. Hopefully that answers the question. Cause, if there's anything else you want to add, then go ahead. Otherwise, I think that'll be it.
No, I think we're good. Thank you.
Okay. Well, guys, thank you very much for joining us. We will be running further webcasts down the line. We think that, as I do a lot of work with the OPC Foundation, I know that there's so much that OPC UA has to offer, but at the same time, when there's that much to offer, there's also a lot to understand and just to be aware of what's actually provided and the power that gives you. So just talking with the guys with Beeond, we're going to be running additional webcasts. So again, your feedback, whether through the survey or your emails, as far as what you found interesting, what else you would like to learn more about, and of course our own sort of views on what we need to run, we will continue to do it. So keep an eye out for that. We'll be announcing further webcasts down the line. But for now, we're going to call it quits. So thank you very much again. Hope you have a great rest of your day and that you found this useful. Thank you very much.
Welcome to the Industrial Revolution of the 21st century. The world of machines and the Internet have become one. Everyone wants to embed connectivity into everything. Of course we do. We need to connect devices to each other, to servers, and to the cloud. And that's not all. These connections must be easy, but also secure. And that's where Matrikon Flex OPC UA SDK comes in. It's a single, scalable toolkit for IIoT connectivity. Matrikon Flex allows you to implement OPC UA in a way that realizes the analytic benefits of horizontal and vertical connectivity, while reducing both CapEx and OpEx costs. Let's take a closer look. First, Flex has robust scalability. It's hardware independent, OS agnostic, and able to implement OPC UA in discrete sensors, actuators, PLCs, RTUs, a DCS, and even high-performance servers. Second, Matrikon Flex is easy to use. It employs the powerful functionality of OPC UA without a PhD in the nuances of multiple development products. Third, Flex protects CPU resources. You do not want a CPU hog. Fourth, you do not want a memory hog. Flex protects your memory footprint. This means that Matrikon Flex has a really small footprint. And fifth, Matrikon Flex OPC UA SDK has broad compatibility with platforms and toolchains. We're talking 32-bit and 64-bit architectures, clear as well as obfuscated source code. We know that you want a high-performance SDK that will run on a wide range of processors, and we also know that we need to support common communication transport protocols. So we do. Plus, we check all the other boxes that reduce time and costs. Language support? Check. Third-party libraries, use case examples and API references? Check, check, check. Personal assistance to handle your technical and business needs? Check. And a roadmap to the future? Check. You can trust that Matrikon, the world's connectivity expert, has the technical savvy and financial stability to be on your team, whatever the future brings. So here's the bottom line. Matrikon Flex OPC UA SDK checks every box. It's a single, scalable toolkit for IIoT connectivity. So go on, try it. Imagine a world in which Matrikon Flex OPC UA SDK is embedded in everything. Try Matrikon Flex for free at matrikonflex.com.